All right, today we're going to talk about section 9.7, graphs and finding the x-intercepts. And before we and talk about them with the quadratic functions, and before we talk about that, we should talk about what exactly are the x-intercepts in a quadratic function, but also just in general, what is an x-intercept? And when we think about what an x-intercept is, if we have a graph, it's the point where it touches the y-axis. I'm sorry, the x-axis. Now, depending on what we're doing, it could be multiple points. Because if you think about a quadratic function, we have our u, it could go up or down or whatever. And depending on where our axes are, we could have more than one x-intercept where it touches the x-axis. And what is our y value? How high up or down is it? Our y value every time is 0. So we are going to be plugging in 0 for y into our equation to find the x-intercepts. So let's move on to letter A. Find the x-intercepts. Remember, the f of x could be also written as y equals, and it means the exact same thing. So in order to find the x-intercept, we're going to plug 0 in for y. So now this equation looks like 0 equals x squared plus 8x plus 16. Now, when we're solving this, this goes back to how do we solve this type of problem when it's equal to 0? We want to first see if we can factor this. And if we look at this particular problem, we can factor it. Because there's a perfect square, we get x plus 4 squared. And now that it is set equal to 0, we can solve this. We can take the square root of both sides. And the square root of 0 is 0, so we have 0 equals x plus 4. And when we subtract 4, we get that the x-intercept is at negative 4. So the ordered pair at which it touches the x-axis is negative 4, 0. And it happens to only have 1 because with it being a perfect square, it was on negative 4 both times. So let's move on to letter B. X squared minus 2x minus 5. Same thing, we're going to plug 0 in for y. So 0 equals x squared minus 2x minus 5. Again, first look to see if that we can factor this. And when I think of two numbers that multiply to negative 5 and add to negative 2, I can't come up with anything. So because I can't factor, I'm going to look at using the quadratic formula. There's other methods you could use. You could even complete the square. But I'm going to go with the quadratic formula. So why don't you go ahead and plug it into the quadratic formula or the complete the square and see if you can find out what x equals. Go ahead and pause the video and do that. And so when you do this, your a value is 1, b value is negative 2, and your c value is negative 5. Plug it in. So then when we simplify underneath in the discriminant, which is the part underneath the square root, you get plus or minus the square root of 24. Then we need to simplify the square root of 24, which is 2 root 6. And we should get 1 plus or minus root 6. So when we think about writing our x-intercepts as ordered pairs, it is 1 plus root 6, and then the y value of 0, and then 1 minus root 6 with the y value of 0. So in this case, we have our two x-intercepts. Let's take a look at one more example. Negative 2x squared minus 4x minus 3. Let's go ahead and take a look to see if we can factor this. And after looking at this and trying to factor it, I can't find a way to factor this, so I'm again going to go with the quadratic formula in order to solve for our x-intercepts. So when I plug this in, go ahead and take a look and make sure that you have it plugged in correctly. This time when I simplify underneath the square root, I see that it's going to be the square root of 16 minus, and that would be 1224, which means I get the square root of negative 8. And we need to remember what we think about when we have the square root of a negative number. When that discriminant is less than 0, we have no real solutions. We would have an imaginary number, so there are no x-intercepts on our graph. And that concludes the notes for section 9.7.